Hello, my fisheries related friends in the Maldives and abroad. I'm Ali Naeem, and this is a video I'm recording today, the 17th of April in the year 2019. In the process of shooting this video, I'm reminded of how quickly time flies by, and I'm filled with memories and emotions of days long gone. It has been ages since I last put my own hands on the work I'm about to show through this video I'm recording now. I apologize for the poor quality of the video as I'm shooting this with my mobile phone. Despite the shaky video as I walk inside this facility, the FAD center, I think this video will serve the purpose. By the way, in case someone wonders, FAD stands for Fish Aggregating Device, which is a device consisting of a floating structure attached to a buoy anchored in deep ocean for the purpose of creating a habitat where large schools of fish are attracted to the area where the FAD is installed. These shiny red buoys are some of the products that have been recently constructed at this facility. This video recording is prompted by a requirement to show how the mooring of these things are assembled. Specifically to show as to how the terminations of a special kind of wire nylon composite rope ends are done. It is a tedious, time-consuming, laborious process, and I hope to record the work in progress in a way that will enable a viewer to see the process in detail and understand the how and why it is done the way I am about to capture the process in this video. These are the two halves of the FRP mold used for construction of these FAD buoys. And what we are seeing here are some of the component parts used in the mooring assembly. These are stocks of double braided 20 mm nylon rope and polypropylene rope of the same construction. Chain sections used at the very bottom of the mooring that is attached to the concrete block anchors. And of course the very special braided nylon rope with plastic-sheathed steel wire rope in its core. The sole purpose of this video is about this special composite rope, more specifically on looking at how both ends of a section of this particular rope is terminated for the purpose of FAD mooring. Only the top 300 meters of a FAD mooring is comprised of this specialized rope. The rest of the entire length of the mooring is comprised of double braided nylon rope next to this rope and again double braided polypropylene rope down below. Attached to the lower end of the polypropylene section will be a section of galvanized steel chain connected to very large blocks of concrete used as anchors. The total length of the entire FAD mooring would usually be in the range of 2000 to 2500 meters depending on the water depth at each FAD location. There are over 50 of these FAD systems installed and maintained within the offshore waters across our country, Maldives. We started our FAD program back in 1981 and continue to install and maintain our FAD systems because these have become so beneficial for our fishermen. An almost finished termination of the special nylon wire rope, as we call it. By the way, this rope is a product of our making. Oh, never mind. No need to go into a proper explanation on what I just said. It's a long story that will require another video to tell. But the purpose of this video is not on our FAD systems and its use or how it all works. Nevertheless, we have come a long way since the time we struggled to keep these deep water moorings in place for long. Now these two colleagues of mine are about to begin the process of making the remaining end of this nylon wire rope, fresh from the start, and I have come just in time to capture the process. I will have to spend a good part of today and probably tomorrow doing this, as I have mentioned already, is tedious and painstakingly slow work. One may ask, what's the point? What's the point in using this particular rope in a FAD mooring assembly in the first place? And why this slow and tedious work? And many other questions perhaps? The answer to those questions are long, but the short answers are that we have come to find the use of this rope at the top section of the FAD mooring an absolute necessity. mainly to protect the mooring against fish bite damage and also because of handline fishery that exist around the FADs. The top sections of FAD moorings are found to be vulnerable to damage by nylon monofilament lines and entanglement of hooks used by handline fishermen. The wire at the core of this rope of specialized construction prevents premature loss of FAD moorings. Now, here we see the rope being marked at 3 different points. Because of the way my colleagues have done the markings, it may seem a bit confusing. Actually, the markings are 8 feet, 2 feet, and another 2 feet beginning from the rope end. A sufficiently long section of the rope is needed to be laid out, as we've seen. This is so that the outer nylon braiding can be pulled back from the inner plastic-sheathed wire core by a process that we call milking. I don't know if that is a term appropriate or adequate to explain the procedure, but that is what it is called, as far as I know, milking. This is a video, so I need not explain any further. That is one reason why I strongly feel the need for this instructional video over written instructions on how to do splicing of this nylon wire rope. Now fasten this part of the rope section, like so. As this is going to be a long process, I shall speed up the video from time to time. Anyone who wishes to see the process in real time may slow down or pause during playback, if need be. And then the process of milking, pulling back the outer braiding until the 12 feet mark. And securing the braided section at this point with some tape. This is temporary. Now cut off 4 feet off of the wire rope. This will give the extra length needed for re-braiding or weaving of the nylon strands, as we will see later in the video. Now remove the plastic sheath from the wire rope all the way from the mark shown. Unwind and part the wire rope into two segments, like so. Make an eye loop as shown. Secure each strand with thin but sufficiently strong enough tape. Electrical insulation tape does an excellent job here. Now weave or wrap the wire strands as shown. Once complete, it will look like this. In this particular instance, the last wire strand did not fit nicely as it should. There must be a mistake here. I think the last strand was not taken from the correct point and so did not fit into its channel along the splicing. Anyway, this is not a problem as this in any way will not compromise the reliability of this splicing. Only an aesthetic problem. No big deal as can be seen later. Nylon monofilament is wrapped around all along the wire splicing as we see here. As this is tedious and slow work, my colleagues are going to call this a day. So we shall continue to film after a break and end this video and call this part 1. In part 2 we will see the remaining work.